solids with known cross-sections. Volumes of solids and known cross-sections. You guys should already have most of these notes already, or the beginning part anyway. So you have all the formulas and stuff written down. And so today I just wanted to get after it and do a couple problems. Emphasizing that A is the area of the known cross-section. Using all your geometry formulas that you know or that you have to develop. A is the area of that cross-section. And then stacking those cross-sections up together is creating that volume, and that would be the integral process. And with respect to x, which means perpendicular to the x-axis, and with respect to y, be perpendicular to the y-axis. Fairly easy, just got to make sure you keep an eye on what's the top function and bottom function. Because the big idea is the distance between the two curves helps getting us the length of the side of that particular cross-section. All right, find the volume of solid in which the base is bound by a region. Base is the region bound by the graphs of f of x and g of x and x equals 0. I believe this is the first problem that she went through in the second video, if I remember right. It's been a while since I've watched those. But I think we're gonna do this one together. Again, it'd be nice because afterwards we're going to use the same problem and look at different cross sections. Okay, and that's how your worksheet is. It's one set of equations. Then you do 5 questions with the one set of equations. So we're going to do that here. Except for I'm not going to do part E because I want you guys to think about part E a little bit more. Okay. Let's graph these. Okay, that's a linear function. It's confusing because x is up here, but it's linear. Y-intercept 1, slope -½ So we got y-intercept 1 and slope of -½ So down 1 over 2, down 1 over 2, up 1, back 2. Little old year algebra 1 refresher. Again, I like to label this f of x because then I know which one's up and lower. Y-intercept -1, slope of +1/2. So y-intercept -1, slope of +1/2, up 1 over 2. That's nice. Intersect at 2, up 1 over 2. And yes, we normally would have to set f and g equal to each other to find that point of intersection. But if we graph them and it easily is available to us, we really don't need to set f and g equal to each other, right? We could solve really easily. And then x equals 0, so that means this would be the base of those cross sections, right? Okay. Now, it kind of sucks because this is a two-dimensional figure. You're looking straight on. Now, if this was slanted a little bit, then I can draw those three-dimensional figures by using like the z-axis. I'm using quotes, right, to plot or to show these squares. But I'll draw something here so we can get a feel for it. The cross-section perpendicular to the x-axis are squares. So this is the base of a square. Okay, how is it going to look? I'll draw something real quick. So it's going to look maybe something like this, right? If it came off the paper, that would be one side, and this distance is the same as this distance. That means if there's another square up here, it's going to be a little bit shorter, right? Because of the width is the same as the height, right? Because we have a square. Okay. You'd be stacking all those up, infinitely many, with width basically 0, right? And so you create that three-dimensional object then. Okay, again, what is A of x? A of x is your area of that particular cross-section. So for us, area of that cross-section when it's a square would be side squared. And for S is the distance between the two curves, right? So for this, S equals distance between the two curves. I forgot the right. That would be f of x, which is upper minus lower, which is g of x. So it would be f of x minus g of x, right? Now, there's a couple different ways you can do this. You can come up with S and then simplify it and put it into your integral. Or you can write it as an integral and then simplify the integral, okay? First one, I'm just going to write the integral, okay? Well, we know that's going to be antiderivative from 0 to 2. We're stacking these squares up from 0 to 2. And it's going to be f minus g. all right, would be the distance between the two curves, which is the side length. And we need s squared would be our a of x, right? So it would be f, which is 1 minus x over 2, minus parentheses, -1 plus x over 2. All of that squared, because this would be the distance between the two curves, which is the side length of the square, and our area is side length squared, and then dx. If this was a calculator portion of the test, you could just write this out, enter in your calculator, and you're done. But no calculators for this stuff. Let's see what we can get. Let's simplify inside the square, make this life easier for ourselves, hopefully. Okay. Let's see here, distribute the negative, that'd be opposite, so plus plus, and then this will be negative, right? Okay, why do they like the square one? Because it's going to be upper curve minus lower, and people are going to forget to distribute that negative all the time. It happens, okay? So within the square, we're going to have 1 plus 1, which makes 2, negative x over 2 minus another x over 2. So that would be negative 2x's over 2, which would be negative x. Quantity squared and dx. Okay, now after we have this set up, guys, now we just attack this in any way, the normal way of we would with antiderivatives. In this case, we'd expand and then find the antiderivative. And again, this seems like an easy problem, but people forget how to expand this, and it shouldn't be that tough. 2 squared, 2 times -1, and then negative x squared, and then dx. Keep going. So would that be 4x minus x squared, and then 4 divided by 2 would be 2, and then plus 1/3 x cubed. Or evaluate it from 0 to 2. I like that. Okay, substitute and evaluate. So it'd be 4x. I forgot an x right here. Why didn't anybody say anything? 4 times 2 minus 2 times 2 squared plus 1/3 times 2 cubed. And then minus 0, obviously, right? We can see that pretty clearly. So that'd be what, 8? 8. Well, that's nice. 8/3. So the answer would be 8/3 units cubed. Okay with that so far? All right. So the volume would be 8/3 units cubed for this right here. Right? Ms. Bonnie, this is symmetric about the x-axis, FNGR. Could I just say 2 times the antiderivative of f of x, dx, squared, obviously? Yeah, I wouldn't do that too much, though. Gotta be careful with that. Okay, any questions on this? The theory, anything? Just review what they already did, right? Okay, now let's look at if the cross sections were semicircles. Okay, so what's the area for a semicircle? 1/2 pi r squared. That would be our a of x, right? The problem is, in this formula for area of a semicircle, we have radius, and they're going to give us the diameter, right? So in this particular situation, we'd have 1/2 pi. The radius is 1/2 f of x minus g of x, right? Squared, right? That'd be the area of that semicircle then. Well, let's do something with this. You know, if we have a product and we have an exponent, that would be the same as the product of each exponent. So it'd be 1/2 pi, it'd be 1/4, and then f of x minus g of x squared. That'd be 1/8 pi, and then f of x minus g of x. And that's where they get, for your formula, they gave you the formula already for an area of a semicircle. It'd be 1/8 pi r squared. They already gave you guys that, right? I shouldn't say r squared. This would be x squared or whatever they might say, which would be the distance between the two curves, right? So that's where that eighth comes from the expansion of this. Okay, so for us then, let's write out our antiderivative. This will be antiderivative 0 to 2, 1/8 pi, and then it's f of x minus g of x squared. F of x would be the, well, we know what f of x minus g of x is, right? It's just 2 minus x, right? Squared and dx, right? Now, on your worksheets, guys, I want you to write out at least this much when you write this out. And then because we've figured out, I'll show you in a minute. What's going on? Sweet, thank you. Since we've already done some of this work already up here, we can just use that answer again. I don't need you guys to find the antiderivative of this 5 times, if it happens to be, okay? Because we've done that already. You see what happens, this constant goes out in front. So we basically have 1/8 times pi, antiderivative 0 to 2 minus x, quantity squared dx. And we've already found that once already. That's 8/3, right? So I'm okay on this worksheet this one time, not just one time, this worksheet, since we're doing the same problem a couple times, if you just make your substitution then, and then 8/3, right? Okay. This is probably why you allow us to do it like this on this worksheet. Well, because number one, you can't use your calculator and save you guys a little bit of time. And number two, the AP test is not going to ask you to take 2 equations and find 14 different solids with known cross sections. They're not going to make you do that. They're going to make you do 1 or 2, okay? And things will be different and they'll change. So we're just going to use, to save some time, use some of our information on again. So 1/8 of 8/3 is 1/3, so 1/3 pi then. Or pi over 3, we okay with that? Units cubed. All right, do you see how I got all those numbers and information? And again, the formula, a of x, that was a semicircle. How do we find that? I developed it, okay? Sometimes they'll give it to you, sometimes they won't. Sometimes they'll give you the formula, sometimes they won't. And the reason why I don't just give you the formulas right away is I like to try and develop it just in case you guys forget the formula or question the formula, okay? We good? All right, equilateral triangles. Equilateral triangle, equilateral, same side. So equilateral triangle, if you guys don't remember from freshman year, or let's say English geometry for some of you guys that took it as 8th graders, equilateral triangle. Okay. Now, if this was sitting on the perpendicular to the x-axis on the graph, perpendicular to the x-axis, it doesn't really matter what side's down. They will say it's an equilateral triangle, right? Well, this is the length between the two curves, right? This would be f of x minus g of x, right? Okay. Well, we could call this, sometimes I call this x, right, in your formulas. Well, how are we supposed to get the height? Because this is a triangle. We know that the area for triangle is 1/2 base times height. Well, what's this angle measurement right here? An equilateral triangle. And this 160. Equilateral is equiangular also, right? Oops, 60. Now, if we drop an altitude, which is a line from the vertex to the side opposite, perpendicular, right? What is this angle now? 30. So we have a 30, 60, 90 triangle. Okay. Now, if this distance across the whole triangle is x, that means that this is 1/2 x. That means we take this side times what to get this? Yeah. You're thinking 1/2 root 3 over 2 and then 1. Yeah. You divide everything by 2, you get that. But anyways, you take the side times root 3 to get that one. So 1/2 x times root 3 gives you root 3 over 2 for this one. Okay, so that's our height, and our base is at 1/2 or x. You would get 1/2. Base is x. Height is √3/2 times x. And so the area for an equilateral triangle actually turns out to be √3/4 x squared, where x is the distance between the two curves, and that's how they get that formula. So for us then, it'll be antiderivative 0 to 2. Our known formula would be √3/4. And again, x stands for the distance between the two curves, right? And that distance, f of x minus g of x, we've already found to be 2 minus x. And then square it, dx. Okay? And then that √3/4 can go out in front. 0 to 2. 2 minus x, quantity squared, dx. Well, we know what that answer is. That'd be 8/3, right? So √3/4 times 8/3. And that turns out to be 2 √3/3. And again, the confusing part is that x is the distance between the two curves on those formulas. I wish we'd call it something else instead of x. All right. Bonus question, letter D. The cross-section perpendicular x-axis are, so ... are rectangles whose heights are 3 times the base. Okay, if they ask us to find area of rectangles, they have to tell us what the height is. Sometimes they'll give us a constant for the height, which turns out to be a pretty easy problem. The rectangle, area of rectangles is base times height, right? And the base is going to be the area between the two curves times the height, which would be a constant. Move that constant out in front, boom. That antiderivative is pretty easy. But here they say the height equals 3 times the base. Okay, area of a rectangle equals what? Base times height. They told us the height is 3 times the base. So that means the area of this rectangle is 3b squared. That's it. Where b is the base, which is the distance between the two curves, which is f of x minus g of x. So if this is our area, we'll have antiderivative 0 to 2. Again, it's a of x, d of x, or dx, I mean. A of x is going to be 3 times the base length would be 2 minus x, right? F of x minus g of x, which we've already found. We have a constant, move it in front. And again, since we have something written in a form that we've already found the antiderivative of, just write the answer in now. So it'd be what, 3 times 8/3 then? And we get 8 units cubed.